The learning target is I can solve real world problems using a scale to determine a missing measurement. A scale drawing is a drawing that shows a real object reduced or enlarged by a certain amount. And so reduced means that it would be smaller than the picture or the original, and then enlarged means that it would be bigger than the picture or the original. So in real life, we might have a giraffe that's 150 inches high, whereas we're going to draw it where it's only 30 inches high. But in order for everything to be in proportion, so it still looks like a giraffe, its neck is still long, its legs are still about the same size, proportional to its neck, we would make a scale drawing. And a scale is the ratio of the length in the drawing or the model to the length in the real thing. So for example, on a map, 2 inches represents 8.75 miles. And we know that as a ratio, we can write it 3 ways. And one of the ways is we can write it as a fraction. So we would write it as 2 inches over 8.75 miles. Question number 1, it says, on an architect's drawing of a house, 1 inch represents 7 feet. So I'm immediately going to write that as a ratio, 1 inch over 7 feet. We keep that ratio together, that scale. If a bedroom window is 5 inches long on the drawing, what will it be on the actual house? Well, we know from proportions that if inches is on top, inches is on top, and if feet is on bottom, feet has to stay on bottom. We keep the units the same. So if the problem says that the window is 5 inches, we know inches is on top, so 5 goes here, and x goes on bottom. And then we would just solve our proportion. We know 1 times x is 1x, and 7 times 5 is 35. We could divide by 1 on both sides, but we know that'll just give us 35. And x is in feet, so let's be proper and let's write 35 feet. So for question number 2 says a blueprint, a scale on a blueprint for a new building is 3 inches to 8 feet. Before I keep reading, I know that's my scale, I'm going to write it as a fraction. 3 inches over 8 feet. The height of the building on the blueprint is 9 inches. What is the actual height of the building? Well, if inches is on top, inches is going to stay on top. If feet is on bottom, feet's going to stay on bottom. And I'm going to go back to my question. It says 9 inches. So I'm looking for inches. Inches is on top, so I'm going to put 9 over x. And we're going to solve. 3 times x is 3x. 9 times 8 is 72. This time we do have to divide because the coefficient is 3, not 1. And now don't forget, it's been a while, but this is 72 divided by 3. Top number divided by bottom number, which will give us 24. And again, x is measured in feet, so we'll write feet, 24 feet. Question number 3. The scale on a blueprint is 1 inch to 6 feet. Mark is looking for a blueprint of a skateboard ramp that shows the ramp's length is 11.4 inches. What is the actual length of the ramp? So we're looking for our scale. In this case, our scale is 1 inch to 6 feet. So I'm going to write it as a fraction. 1 inch over 6 feet. If inches is on top, inches has to stay on top, feet is on bottom, got to stay on bottom. And then I'm going to go back in that question looking for that extra information. It tells me that the ramp is 11.4 inches, which means that my 11.4 is going to go next to my inches and my x will go next to my feet. So 1 times x will give us 1x, and 6 times 11.4 will give us 68.4 feet. Again, we could divide by 1 on both sides. It will give us the same answer, 68.4. If 1 inch represents 2.5 feet, what dimensions would you use to make a scale drawing of building that is 34 feet? So we need our scale. Our scale in this case is 1 inch represents 2.5 feet. Inches on top, feet on bottom. I go back into the question, what dimensions would you use to make a scale drawing that is 34 feet? Well, this time we got 34 feet on bottom and we're looking for the inches on top. So 2.5 times x would give us 2.5x, and 34 times 1 would give us 34. Divide by the coefficient, this time it's 2.5. And again, this is saying 34 divided by 2.5, which is going to give us 13.6. And now x was inches, so it's 13.6 inches. And our last question is the state test question. It says that the scale of a model train is 1 inch to 13.5 feet. One of the cars on the model train is 5 inches long. What is the length in feet of the actual car? Well, we know our scale, 1 inch to 13.5 feet. We keep that scale together, we write it as a fraction. 1 inch to 13.5 feet. It's a ratio. We can write ratios as fractions. If inches is on top, we keep inches on top, feet is on bottom. We go back and it says that train is 5 inches long. So 5 is going to go on top next to my inches. And it says, what is the length in feet? That's what we don't know. That's why we put an x there. And then we can solve. 1 times x will give us 1x. And 13.5 times 5 will give us 67.5 feet. So choice A would be our answer.